Hi everyone, welcome to AAT Tech Talk of Engineering Physics. I am V Sai Charan 21951A04G0 of branch ECE section. In this presentation, I am going to talk about complex design for distributed quantum computing. Computing generations. First generation 1940 to 1956 vacuum tubes. Second generation 1956 to 1963 transistors. Third generation 1964 to 1971 integrated circuits. Fourth generation 1971 to now present microprocessors. Fifth generation present and behind artificial intelligence. Overview. Brief history computing generations. Current technology limitations. Theory of quantum computing, how it works, applications, timeline, questions. History. Abacus, gate driven, integrated circuits, over 200 million transistors. Moore's law. In 1965, Jordan Moore predicted that number of transistors per square inch on integrated circuits had doubled every year since the integrated circuits was invented. Morse predicted that this trend would continue for the foreseeable future. This has held true so far. Moore's law constant. Recently, Jordan Morse announced that his prediction in 1965 would not remain true for much longer. The microprocessor industry was getting closer to the limits of the current technology. The ability to put transistors on chips was approaching the atomic level, stretching the limits. Intel has announced new SRAM RAM chips for high density memory. Contains 330 million transistors. Pentium 4th has 30 million transistors. Problems. Current technology is not having difficulty adding more transistors. At current rate, transistors will be as small as an atom. If scale becomes too small, electrons tunnel through micro thin barriers between wires corrupting signals. Quantum computers. Completely new approach to computing uses quantum practicals to achieve computation. Still theoretical. Entanglement. Albert Einstein baffled. Coined phrase Spocky action at a distance. Still remains a mystery. Superposition. Two states are better than one. Digital computers rely on 0 and 1. So, voltage produces high and lows, can only have one state. Quantum computers have a multiple states, two places at once. Example: reflecting photons of silvered mirror defaults off the light. Where do you think the photon landed? Example: constant. Proof: both detectors record photon. Qubit. Quantum bit is in superposition 0 and 1. Why this is helpful? You can observe in the figure input register and output register. Multiple computations simultaneously. Computing power is exponential. Digital versus quantum. Digital produces serial results even with threads. Quantum is truly concurrent. Digital computers need an exponential amount of resources to accomplish a task. Quantum computers only perform to n computation. N is equals to number of bytes. The larger the problem. Because of the exponential factor, the larger computations save more resources than smaller ones. Adding large calculations to exciting algorithms does not complicate computation. Efficiency due to qubits. Power of logarithms. Multiplication logarithms assigned in large computations. Quantum logarithms can speed up processes by using logic. Instructions such as to so on and now take a superposition of all numbers from the previous operations to so on. Logarithms constant will be exactly effective in any logic. Basic logarithms such a factoring large numbers. Logarithms are not just theoretical anymore. In 1994, Peter Shaw of Bell Labs devised a polynomial time logarithm for factoring large numbers on a quantum computer. Status: quantum logarithm does not exist. Peter Shaw. Intellectual hives devoted to quantum computing. Oxford University. University of Innsbruck, Australia. Boulder, Colorado Labs of the National Institute of Standards Technology (NIST). Los Alamos National Laboratory, Massachusetts Institute of Technology, many others. Even Microsoft Research in Raymond Wash now counts a quantum computer scientist among its theorists. Status count. Rudimentary quantum computers exist. December 19, 2001. IBM performs Shor's logarithm. Quantum computing is so complex that expanding one on simple operations is still 10 to 20 years away. Most well known QC is based on nuclear magnetic resonance NMR, who's, who in quantum computing. Albert Einstein theorized about quantum computation. Richard Feynman considered dimension of quantum mechanical objects by other quantum systems. In 1982, Peter Shor developed first quantum algorithm. In 1994, a ton of well formed teams. Timeline. Desktop quantum computers expected by many within 20 years, faster than anticipated progress. progress. Thank you, everyone. By this, I will end my presentation.